Hi, in the last video we looked at how we could, given the magnitude and direction of a vector, determine its scalar components. In this video, what we want to do is look at how we could, given the scalar components, determine the magnitude and direction of the vector. By direction, I mean the angle measured counterclockwise from the positive x direction to the vector. Before continuing, I'd like to emphasize the importance of being able to work with the components of vectors. It is very important for you to find the scalar components of vectors and, given the scalar components, be able to determine the magnitude and direction of the vector expressed as some angle. Now, why is this important? Well, it is important because we will be doing a lot of vector addition, and the method that we'll be using will be based on the components of vectors. So make sure you get this. In this example, the scalar components are minus 4.5 and 5.36. That means this vector component is 5.36, 90 degrees, and this vector component is 4.5, 180 degrees. So given this information, what we want to do is find the magnitude of this vector and its direction as an angle counterclockwise from the positive x-axis. Finding the magnitude is fairly simple. We simply apply Pythagoras' theorem. So that's going to be the square root of the sum of the squares of these sides. So you can simply say that's vx squared plus vy squared, square root of everything. We can put negative signs in here. I didn't bother to use absolute values because the square will make this number positive anyway. So when you do that with these values, notice we get 7. Now to find the angle, we could find it this angle or this one to start with. But since we want, in the end, the angle from the positive x-axis, well then perhaps this angle would be better to work with. So I can toggle that angle, and there we have it. And so this angle in here, let's assume this applet didn't tell you it's 40.02 degrees, can be found by finding the angle whose tangent is this side over this side. So that's the arctangent of the absolute value of Vx divided by the absolute value of Vy. The angle then is going to be the angle whose tangent is the length of this side divided by the length of this side. So that's the absolute value of Vx over the absolute value of Vy. Notice this length is the length of Vx, this length is the length of Vy. So that's the arctangent of 4.5 divided by 5.36. That gives me 40.02. And so I can express this vector as a vector whose magnitude is 7 meters per second, and the angle would be 130.02 degrees. So remember, we're finding the angle measured counterclockwise from the positive x direction, and so I simply added 90 degrees to this. I could have worked with this angle here, in which case I'd have gotten 49.98, and then to get this angle over here, measured from the positive x direction, I would have had to subtract this from 180. Either way, we get the same answer, 130.02. So you're going to need to know to do these calculations, but you can always use this app or some other one that you prefer to check your answers. We could look at another example. Let's suppose we make, so in this case, perhaps it'd be easier to work with this angle. Again, it's up to you. You could work with this one. So this angle is the angle whose tangent is the ratio of this side to this. So that's the ratio of the length of Vy over the length of Vx. That gives me 47.29. Of course, the magnitude is what we get applying Pythagoras' theorem. And we add this to 180 to get the angle measured all the way from over here. So I could just do that and we see we get 227.29. So we're going to practice a few of these in class. It's very important you get this. Vectors are going to be found throughout this course, and you find them in other areas also, computer science, graphics. So make sure you understand this. It's very simple. If you're seeing this for the first time, it might seem a bit scary, but with familiarity, it becomes easy. Okay, so that's it for this video. Bye for now.